Okay, so now I'm going to talk about the non-homogeneous second order ordinary differential equations with constant coefficients. So previously we have already done the discussion about the homogeneous second order ordinary differential equations. So the non-homogeneous equations are something like this. So for example, second order y double prime plus a y prime plus b y is equal to some function r of x. Okay, some function is over here. So we have to find the solution. So the solution of this non-homogeneous equation is given by this expression. So y is equal to, y is the general solution, is equal to the solution of its homogeneous component and plus a particular solution. So the homogeneous solution is determined by the characteristic equation on the left hand side. Okay, and then in homogeneous case Rx is equal to 0, and the other solution, which is called as, which is represented by yp, particular solution, is dependent on this function Rx, and the solution, generally speaking, the solution of yp is similar to the function Rx. So for example, if this function Rx will be an exponential function, so the solution of yp will be also in terms of the exponential function. If this function Rx will be in terms of the trigonometric function sine and cosine, and yp will be also in terms of the sine and cosine. So there are certain rules for the type of Rx and the type of solution, and these rules have been presented by table 2.1 in your textbook. So this is the table 2.1. Okay, so let me show it a little bit smaller so that it can fit in screen, on screen. Okay, so this is table 2.1. So this table 2.1 shows that to determine the solution yp, we have to see the type of this Rx. So if the type of Rx is exponential, then the choice for Rp will be also an exponential function. If the function Rx is a polynomial, the choice of yp will be also a polynomial, and similarly others, cosine and sine as well. In order to apply to find this yp, we use a method which is called as the method of undetermined coefficients, which is quite straightforward and intuitive, and so this will be best. It will be best if I will be able to explain better when I will do the example. And similarly, there are also three rules which need to be followed. I will explain the rules when I do the example. So let's go ahead, and then I can show you some numerical, I can show some solution. Okay. So suppose if the differential equation is this, y double prime plus y is equal to 0.001 x square, and it is an initial value problem. Y 0 is equal to 0 and y prime of 0 is equal to 1.5. So we have to find this solution. So this is a non-homogeneous differential equation. So first of all, we will find the solution of the homogeneous equation. Y double prime plus y is equal to 0. So we can easily say that its characteristic equation can be represented by m square plus 1 is equal to 1, or in this case m will be equal to plus minus I. So it has complex conjugate rules, and we can immediately say that the homogeneous solution will be equal to in terms of cosine and sine, because if it is the complex conjugate, so the homogeneous solution will be in terms of cosine and sine. So it will be a cosine of x plus b sine of x. Okay, so we already know very well how to find the homogeneous solution. So let's come to the particular solution. So for the particular solution, we will need to see this Rx term. This Rx term is a polynomial. Okay, so if it is a polynomial, so its solution will be represented in this manner. So starting from the polynomial's highest power, we will decrease the power by 1, and then in the end there will be a last term which will be with power of 0, x to the power of 0. So in this case, then for the matter of undetermined coefficients, so we can assume some undetermined coefficients for the particular solution of y. So in this case, let me show you that the particular solution we can represent in the form of this Rx. So it will be a x square plus b x plus c. Actually, I have already used a and b, so maybe it's better I should not use a and b again. Maybe I can use some other. C, D, and E. Okay. So basically we are saying that the solution, the particular solution will be in this form. Okay. So in this form it will be there. So if it will be there in this form, then we will need to determine the coefficients C, D, and E. C, D, and E. So C, D, and E are undetermined coefficients. Okay, so that's why the name of the method is the method of undetermined coefficients. So these undetermined coefficients have to be determined. So the technique is quite straightforward, because since we say that this is the solution, so this solution must satisfy the original differential equation. So for this we need to take the derivative. So we take the first derivative, so it will be 2c x plus d, e will become 0. We will take the second derivative, it will become 2c only. So now we will input these into this differential equation. So y double prime p is equal to 2c, and y is cx square plus dx plus e, and that should be equal to 0.001 x square. So in order for this equation to hold true, the coefficients of x square should be equal to the coefficients of x square on this side. The coefficient of x on this side should be equal to the coefficient of x on that side, and similarly coefficients of these c and e, that means x power 0, should be equal to here. So by this then we can get three equations. So from the coefficients of x square, so there is only one x square term over here, so this c is equal to the coefficient of x square on this right hand side, so it will be 0.001. So in fact we have found that the value of c is 0.001. For now we compare the coefficients of x. Coefficient of there is only one x term over here, but there is no x term over there. So it means that the coefficient of x term on the right hand side will be 0. So that means then d will be equal to 0. On the other side, similarly 2c plus e, there is no corresponding term over here. So 2c plus e will be also equal to 0. So since we know the value of c, we can put the value of c here, 0.001 plus e is equal to 0. So e will be equal to minus 0.002. So in this way we have found the particular solution. Okay, so the overall solution will be then homogeneous solution, a sine of x plus b sine of x, plus particular solution, which will be cx square, which is 0.001 x square, and d was 0, so there would be no x term, and then plus e, and e is minus 0.002. Okay, so since this is given as an initial value problem, so we can immediately find the value of 0, because y0 was 0. So y is 0. This is a, then that will be 1, because cosine of 0 is 1, and all other terms are 0. Sin x and these terms are 0, and then the last term is minus 0.002. So from here we can find the value of a is equal to 0.002. And since y prime is also given, so y prime is equal to minus a sine x plus b cosine x plus 0.002x, and then the last term is 0. So y prime 0 is equal to 1.5, that is given. So from here we can find 1.5, y prime is 1.5 is equal to, then this is, because this term will be 0, because sine of 0 is 0, then this term is b, that is 1, and then the last term, that is also 0. So b will be equal to 1.5. So now we have determined a, now we have determined b. So the final solution of the initial value problem is equal to, a was 0.002, 0.002 cosine of x plus 1.5 sine of x plus 0.001 x square minus 0.002. So this is the solution of the initial value problem, non-homogeneous differential equation.